I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we are going to discuss the topic Optical Transmitters and Receivers for the unit Optical Networks. So first we are going to see the optical transmission systems. So the optical transmitter is a device that generates the signal which will be applied or transmitted through optical fibers. So the optical fiber block diagram, transmitter block diagram is shown here. So here we have at the input side electronic wire input with electronic pre-processing and drive circuit, and we have an optical monitoring with the drive circuit. Light source is connected. Light source output is given to optical monitoring, and again there will be a feedback loop here, and light source output is also given to temperature monitoring. If it is needed, a cooler is supplied, and light source output again given to external modulator and for modulation purpose, and the attenuator, if it is high amplitude, that will be attenuated, and at the output side we get a fiber output, and we have optical interface at the output side and electronic interface at the input side. And this is the optical transmitter block diagram, and we will see one by one. So first one is electronic interface. So there is wires, standard electronic connections or pins energizing the transmitter. They provide power electronic input and output optical signals. And electronic processing unit. In some transmitters, the input electrical signals are electronically processed to put them into a suitable form to drive the light source. And another important circuit is the drive circuit. This depends on application, requirements, data format and the light source. So electronic interface, electronic processing and drive circuit. And next is the optical monitor. So the function of optical monitor is to monitor the output of laser and provide the feedback to the drive circuit so that the output power remains stable. And there is also a temperature monitor. So the characteristic of semiconductor laser changes with temperature. So the lifetime of laser decreases with increase in operating temperature, and the output power also decreases, which produce some change in output wavelength of the light. So in order to keep the operating temperature stable, the thermoelectric coolers are used in optical fiber transmitters, and these coolers control the temperature of the light source laser. And we have optical modulator. Optical modulator, the electronic electro absorption modulator, it is called as EAM, which is small and can be driven with a reasonably small voltage swing. Electrically, it is a reverse biased PN junction. And there is one more modulator called Mach-Zehnder modulator, generates the highest quality optical pulses with a controlled amount of chip with high conjunction ratio. Electrically, it is a transmission time, and the maximum transmission distance can be achieved in an optical communication system is determined by the combination of chromatic dispersion limit, the polarization mode dispersion limit and the attenuation limit. And the system architecture. So from architecture point of view, the fiber optic communication can be classified into three major categories. The first category is point to point link, next is the distributed networks, and finally the local area networks. And now we are going to see the point to point link. So a point to point link comprises of one transmitter and one receiver, so that it is called as point to point link. This is the simplest form of optical communication link, and it sets the basis for examining complex optical communication links. So for analyzing the performance of any link, Following important aspects are to be considered. These are distance of transmission, channel data rate, bit error rate. So all above parameters of transmission link are associated with the characteristics of various devices employed in the link. So this is point to point link, and when the link length extends between 20 to 100 kilometer, losses associated with fiber cable also increases. So what happens is, to compensate the losses, optical amplifier and regenerators are used over the span of a fiber cable. So a regenerator is a receiver and transmitter pair which detects the incoming optical signal and recovers the bit stream electrically and again convert back into optical form by modulating an optical source. So, and the optical amplifier amplify the optical bit stream without converting it into electrical form. And there is a parameter called repeater spacing, which is the spacing between two repeaters or optical amplifier, and the repeater spacing is denoted by L, and it depends on the bitrate B. The bitrate distance product is BL is a measure of system performance for point to point link. And now the assessment time. Coherent radiation is relatively directional, and the finite spectral width of the optical source causes pulse broadening. Thank you.